See the next one, state true or false. So they are given 6 statements. Now we have to take each statement and we have to state whether it is true or false. So they are all of same model, same type. I'll just explain you what type they are. See this. Now they are saying that this is some set of elements. Okay. Now let me take the first statement. This set of reflexive relations are closed under the operation set union. Let me say set of all. Okay, the set of all reflexive relations are closed under the operation set union. So what they mean is, if this is the set containing all the reflexive relations, right? So these are all the dots. All these dots are nothing but each dot is a reflexive relation, right? And this is a set of all reflexive relations. Now they are asking, what can you say about this operation? The set of all reflexive relations are closed under set union. It means that if we take any two relations from this set, R1 and R2, which are of course reflexive relations, and if we apply the operation union between R1 and R2, the resulting relation should also lie in the same set, which means the result also has to be reflexive. Then only we can say that the set of all reflexive relations are closed under the set union operation. Okay, that is the meaning of it. Try to understand this statement again. The set of all reflexive relations are closed under the operation set union. What does they mean? What do they mean by that? If you take the set of all reflexive relations, and from this if you take any two elements which are of course the reflexive relations, and if you apply union, if the result also happens to be in the same set, we can say that the set of all reflexive relations is closed under the operation union, right? That is the meaning of this one. So what can you say about it? Is it true or false? So it is true, because if R1 is reflexive, then it means that R1 already contains all the elements required to make it reflexive. What are the elements? Diagonal elements. And R2 is also already reflexive. It also contains the same elements. I mean, not exactly the same, but then it contains all the diagonal elements, and apart from it, it may contain some other elements. But whatever it is, the result is going to contain all the diagonal elements again, because they are going to be present in at least one of them. Therefore the result is reflexive. It is true. So the set of all reflexive relations are closed under the operation set union. So the first statement A is true. Now the second statement says that the set of all reflexive relations are closed under the operation set union. I have just kept the details because they are same. Okay, the set of all reflexive relations are closed under the operation set intersection, which means if you take any relations from here and if you apply the operation intersection, then the result is also going to be reflexive. That is what they are saying. Is it true or false? It is again true. The reason is, if you take any two sets here, any two relations which are reflexive, then they are already containing all the diagonal elements, right? And when you take the intersection of two reflexive relations, in both of them the common part is diagonal elements. Apart from this, there might be some other common part as well, but then the result is definitely going to contain diagonal elements. So what can we say? Yes, so intersection of two reflexive relations is going to be reflexive. Therefore you take any two reflexive relations from this and you apply intersection, it is always going to be one element in this. Therefore yes, they are again closed. True. So the set of reflexive relations is closed under set intersection and set union. What about set difference? So what do you mean by difference is, if you take one reflexive relation and if you take other reflexive relation and if you apply difference, then they are asking whether the resulting is also going to be reflexive or not. It is not reflexive. The reason is, if R1 is reflexive, it contains all the diagonal elements. If R2 is reflexive, it contains all the diagonal elements. When I apply R1 minus R2, the result will be R1 from which all the diagonal elements are removed and some other elements may be removed, but whatever it is, the result will not contain any diagonal elements, right? Therefore the result is going to be not reflexive relation. In fact, it is a reflexive relation. Therefore it is not closed. So if you didn't understand this point, try to see this example. What I mean to say is, let us say A equal to 1 2 3, right? Now let us say R1 is a reflexive relation, which means 1 1 2 2 3 3 is present, and along with that I'll just put some other element 1 comma 2. So let's say R1 is this, and R2 is also reflexive relation. Then R2 will also contain all the diagonal elements 1 1 2 2 3 3, and along with that it may contain some other elements. Let me put 2 comma 1, something like this. Now when I apply R1 minus R2, then what happens is this R1 minus R2 is going to be all the elements in R1 from which the elements in R2 are removed. Then what do we get? 1 comma 2. So what does it mean? All the diagonal elements, since they are present in R2 as well, all the diagonal elements will be removed from this, right? Therefore R1 minus R2 will not be reflexive, right? So it will not be present inside the set. Why? Because the set contains only reflexive relations. Therefore we cannot say that the set of all reflexive relations is closed under set difference. It is not closed. Got it? And one more point is, if R1 is reflexive and R2 is reflexive, then definitely R1 minus R2 will be irreflexive. Why? Because from R1 we are removing all the diagonal elements which are also present in R2. Therefore the result will be a relation in which no diagonal elements will be present, right? Since they are present in both of them, they'll get cancelled out. So the result will be a relation in which no diagonal element is present. So R1 minus R2 is going to be irreflexive always. If R1 and R2 are reflexive, then R1 minus R2 is going to be irreflexive always, right? Okay, the next one is the set of all irreflexive relations are closed under union, which means, now let us say this is the set of all irreflexive relations. Now they are saying if you take two irreflexive relations from this and if you apply union, whether the result goes into the same set, which means the result is also irreflexive or not. That is what they are asking. If R1 is irreflexive and R2 is irreflexive, it means that both of them doesn't contain any of the diagonal elements. Now when you apply the union, definitely the result will not contain any diagonal elements, because the two ingredients R1 and R2 which are used to form the result does not contain any diagonal elements. Therefore it is true that if you take two irreflexive sets and apply union, the result is irreflexive. Therefore the set of all irreflexive relations are closed under the operation set union. It is true. What about the next one? The set of all irreflexive relations are closed under the operation set intersection. Again it is true. The reason is both of them are not going to contain any diagonal elements. Then intersection will definitely not contain any diagonal elements. Or in fact we already have seen that if R1 and R2 are two irreflexive relations, so R1 intersection R2 is a subset of one of them, either R1, or you can write it as is a subset of R2, and we already know that every subset of irreflexive relation is irreflexive. Therefore this is irreflexive. It is true. What about set difference? So set difference is also going to be irreflexive. If R1 is irreflexive relation and R2 is irreflexive relation, if I write R1 minus R2, it is nothing but from R1 we are going to subtract or delete some of the ordered pairs. Already R1 does not contain any diagonal elements. Now by deleting some of the elements from R1, I am not actually adding any diagonal elements. Therefore the result will be a relation which will not again contain any diagonal elements. Therefore R1 minus R2 is going to be again irreflexive relation only. Therefore it is closed. It is closed under set difference operation. Got it? Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.